So before we get going today, I want to draw your attention to two special logs. One of them we talked about last week. One of them is kind of brand new today. Okay? So the first special log is natural log, ln. Okay? Natural log is logs base e. Okay? So instead of writing log, we write natural log. Okay? Instead of writing log base e, we write natural log. Likewise, if it's a natural log problem and you're switching it back to exponential form, your base is e. Okay? That's the first one. That's the one we talked about last week. Okay? The second one is what's called common logs. Common logs are logs base 10. Okay? And we don't write anything. Okay? It's just the word log. We don't write the base on it. So if you see a log without a base on it, it's assumed that the base is 10. It's called common logs. Okay? All right? These two are also keys on your calculator. Okay? Natural log is the ln key on your calculator. Log, common log, log base 10, is the log key on your calculator. Okay? Alright? So I wanted to talk about those so that you guys have those written down for you so you can go on for this chapter. What I'd like you to do today as a warm-up is I would like you on page 812, I would like you to fill in that chart. Okay? So what does the logarithmic form start with?
E.
No. What does the logarithmic form start with? Log. Okay. So this one would be log. Whoops, tap the brakes, got to get the marker going. Log base 12 of equals
E.
2. Exponent. 2. Okay? So that one written in log form is log base 12 of 144 equals 2. And that's how we read it. Okay? Somebody shout it out loud for the next one.
16 to the 1/2 power equals 4.
That was nice shouting out loud. Next one. Looks like we're looking for log form again.
Log 10. Or log 10. Let me see. Log 10.
I would say it just as log because we don't say base 10, right?
Yeah.
We just say log.
Log 10.
Log
Log
of,
10.
no.
You don't have to say 10.
You don't have to say the 10. When it's 10, you don't have to say it.
Okay, so just log.
Log of 100,000 equals
5.
next one. Somebody that hasn't said anything yet? What you got, Brett?
E to the 3rd power equals 20.086.
0.86, yeah. Okay. Next one. We got Shane. base 2/3
with the exponent base 27
of 8/27. That's not an exponent. Okay? That's a whole other number. Equals 3. Okay. Got the next one, Luke?
20.
Nope.
No, 9
Yep.
to the 1/2 power.
3/2 power
Oh, 3/2 power equals 27.
equals 27. Okay. Next one. Anybody?
2 to the 8th power equals x.
Next one.
Log 6 to the 36 equals x.
Log
6. Log base 6.
base 6
to 36 equals x.
of
Of 36
X equals.
and what?
X equals.
X would equal 2 there, yeah? Okay. All right. Now, the only thing that's different this week from last week is instead of saying answer, which we said last week, okay, the book is calling that the argument now. Okay? Still an A word. Answer to argument. Okay? So what we said last week and what we just had on that last slide was this was the answer. Okay? But the book is now saying that that's called an argument, which is true, but it's just easier to say it's the answer because it just makes it easier. Okay? The variables of the logarithmic equation have the same restrictions as corresponding variables of the exponential equation. The base b must be greater than 0 but not equal to 1. The argument must be greater than 0, and the value of the exponent has no restrictions. Okay? It is important to become familiar with how the base, the argument, and the exponent fit into the logarithmic equation. A logarithmic equation is an equation that contains a logarithm. To write a logarithmic equation, sometimes it's helpful to consider the exponential form first and then convert it to logarithmic form. Okay? The reason that we're saying that is in chapter 11, which we're starting today, in chapter 11, we are going to be solving logarithmic and exponential equations. And you solve logarithmic equations by putting it into exponential form. You solve exponential equations by putting it into logarithmic form. Okay? You solve them by using the other form. So knowing this up here, which we told you last week to memorize, is going to be extremely helpful starting today. Which is why last week we told you to memorize it. Okay? So if you didn't listen last week and didn't memorize it last week, what do you think your job for tonight is? Memorize it. Okay? Because it's going to make this entire chapter go like that. Okay? If you don't have it memorized, get it memorized. Okay? Now, this paragraph right here, I want to spend like 2 minutes talking about. Okay? So what that paragraph said was that your base has to be greater than 0 and not equal to 1. Okay? We said it in the last chapter as exponential decay functions had bases between 0 and 1, and exponential growth functions had bases greater than 1. Okay? So basically they're saying, right now, it doesn't matter if growth or decay. Okay? We're just concerned that the base is greater than 0, but not equal to 1. Okay? Then it goes on to say that the answer, or the argument, if you will, has to be greater than 0. Now, I'm going to put a little bit of an asterisk next to that, because last week we had answers or arguments that were less than 0. Okay? And we got that two ways. One, we had a negative a value that reflected it over the x-axis. Okay? Or two, we had a vertical shift going on. And then we got some answers less than 0. Okay? Now, in this chapter, we're going to do some math to get rid of both of those. Okay? We're going to get rid of those first and then go to solve. Okay? So we're going to have, whoa, I don't know what's going on there. We're going to have different things going on. Okay? But that's why I put an asterisk next to it. Last chapter, when you're graphing it, they can be less than 0 if you have a negative a value or if you have a vertical shift. Okay? And then there's no restrictions in the exponent. Exponents can be positive, they can be 0, and they can be negative. Okay? So, on page 813, what it's asking there in question number 2 is, you're going to take those three numbers and you're going to rearrange them into a true logarithmic equation. So, I know that 7 squared is 49. Would you all agree with that? Okay? So the true logarithmic equation here would be log base 7 of 49 is equal to 2. Okay? Your job now is to do B, C, and D. Give me one of the three. B, C, or D? Which one you doing?
C.
C? Okay.
Log base 4 of 4 equals 1.
I would agree with log base 4 of 4 equals 1. KG, was that the one that you were going to do too? Okay. Which one would you like to do?
I can do D.
D? Okay.
Log base 4 of 256
Log base 4 of 256 equals 4. Love it. Okay. Luke?
For D, log base 6 of 1 over 216 equals -3.
Fantastic. Good job. Okay. All right. Now, we're going to start talking about solving logarithmic equations. Okay? Now, there's three different parts to a logarithmic equation. There's the base, the exponent, and the argument. So depending upon which one is not given, or which one you have to find, I should say, is how you're going to go about solving it. Okay? So, if the argument is unknown, okay, or the answer, quote unquote, is unknown, then you just switch forms. When you switch forms, it is solvable. Okay? If the exponent is unknown, okay, the first thing that you do is you switch forms. Okay? So you first switch forms. Then you get equal bases.
then if the bases are equal, then the exponents are equal. Okay. If the base is unknown, first you switch forms. Do you see a pattern here? What's the first thing that you should always do? Switch forms. Okay? Switch forms. Okay? And then, now here, what the book did is they got equal exponents, which give you equal bases. Kind of the reverse of this one. Okay? Or you simply could here take the root of both sides. Okay? So you could do that too. You could just take the root of both sides. Okay? Okay. Let's try it. Okay? So, solve for the unknown in each logarithmic equation. So, what's the first thing we need to do? Switch forms. So if I switch this form, I get 8 to the n power equals 64. Agree? Okay. Now you've got one of two questions that you could ask yourself. The first question you could ask yourself is, what exponent can I put on 8 to give me 64? The answer would obviously be 2. Okay? The other question you can say is, how can I make 64 into a base of 8? Well, slap an exponent on there of 2, so n equals 2. Okay? With me? Okay? What I would like you to do now is I'd like you to do B. If I switch forms, I get n to the negative 2 power equals 1/16. Yes? Okay. Which, if I follow along with the book's way logic of thinking, this is n to the negative 2 power equals 4 to the negative 2 power. And since my exponents are equal, then my bases have to be equal. Now, an alternative thinking for that one is I could make this, from my red equation, I could make this be 1 over n squared equals 1 over 16. Okay? Which then would mean that n squared has to equal 16. Cross multiplying, reciprocate both sides, however you want to do it. Okay? Which means then that n would have to equal plus or minus 4. Because if I take the square root of both sides, that's an even root, plus or minus. Right? Why does n equal 4 stay and n equal negative 4 go? I can't have a base that's negative. Okay? Because that's what we're looking for here. We're looking for the base. And according to the rules that we learned back in chapter 10, the base has to be greater than 0. Okay? And then that would give me my n equals 4. Okay? Do C, D, E, and F. For the first one, actually it's the third one. For C, I should say, I get negative 6. Do we agree with negative 6? Questions on getting negative 6 there? For D, I got 1,000th. Do we agree with 1 over 1,000? for D. Okay? Remember that because it was just log, that is log base 10. Okay? No questions? For E, I got 7. N is 7. Do we agree with N equaling 7? Questions on that? Yes, ma'am. Talk it through? Okay. Do you agree with the form switch? Okay. All right. So, do you agree with the cube root of 49 is 49 to the 1/3 power? We learned that like 4 chapters ago. I'm just working the one side. Yep. Okay. With me? Do you agree that 49 is 7 squared? Okay. Do you agree that 7 squared to the 1/3 power is 7 to the 2/3 power? Yeah? Because power to a power, what do? Multiply them, right? Okay? Right? So 2 times 1/3 is 2/3. Okay? So do you agree with the blue line then? I just rewrote the right side. Okay? Now, because I'm in an equation and I got equal exponents, that means I got to have equal bases. Okay? Likewise, if I have equal bases, I got to have equal exponents because of the equation. Okay? So n equals 7. Okay? F. Do we agree with F? Okay? That's about the 4th time I think you've done that problem in the last week, just so you know. Okay? It was an example last week. It was in one of your homeworks, and it was a question on the test, I think. So, okay. All right. And it actually was one that we did today already. Okay. Oh no, there it goes. Okay. So, in question number 5 here, it's asking write 3 logarithmic expressions that are equivalent to each given expression. What does equivalent mean? Equal, okay? So what is log base 5 of 625 equal to?
That would be 5 to the 3rd.
No, 5 to the 3rd is 125. Look.
5 to the x power equals 625.
But what is x then? X is 4. Okay? X is 4. That right there, that's a true statement. Okay? So now give me another logarithmic expression, log base something of something, that's equal to 4. Starts out with log.
Base 5.
Base 5. I mean, that's going to give me that one right again.
I'm sorry. Log base 1.
Log base 1 can't be.
Log base 1.
Give me something easier.
Log base 2.
Okay? So log base 2 of what is equal to 4?
6.
Log base 2 of 16 is equal to 4. Give me another one. Log base 3 of, nope. Log base 3 of 81 is equal to 4. Give me another one. Log base 4 of what? Nope, that's 7. Actually, no, that's, I don't know what that one is.
256.
256. We did it earlier in one of the problems. 256. All of those are equal to 4, right? You want to get another one?
Log base 6 of 1,296.
1,296 or 300? Which 200?
I think it's 296.
I think it's 296. Yep. Okay. So all those are equal to 4, right? Okay. Which means then that all of these are equivalent. They're the same. Okay? It's like 1/2, 2/4, 3/6, 4/8. They all mean the same thing, right? Put that phone away. They all mean the same thing, right? Okay? All 4 of those mean exactly the same thing. Okay? Have a good day.